Hello, my name is Mike Negretti, and I'm a design engineer for power products and linear technology. Today, I'm going to show you how to design a simple isolated flyback inverter. Normally, you don't hear the term simple associated with isolated flybacks, but a new device called the LT3573 really does make it so. Isolated power supplies are needed in a wide variety of applications. Galvanic isolation is achieved using a transformer or optocoupler, which ensures that no DC path is present between two circuits. Isolation is desirable for many reasons, including safety, noise immunity, and circuit protection. A flyback inverter is an excellent choice for many isolated power applications and will be the focus today. In a flyback, the transformer serves two purposes. It's used as an isolation device and also as an energy storage device. In textbooks, they teach us that the transformer's secondary winding current is a multiple of the primary winding current. This is not true for a flyback inverter because the transformer has a low magnetizing inductance, which is infinite in the ideal textbook case. During the switch on time, the input voltage across the primary winding magnetizes the transformer's core. When the switch turns off, the core releases the energy to the secondary winding through the diode to the output. An isolated flyback inverter needs access to the output voltage information in most cases. This output information is sensed with a secondary side regulator and then transferred across the isolation barrier with an optocoupler. This is a flyback inverter implemented with a optocoupler and secondary side regulator. Please keep in mind that there are a dozen more primary side components that are not included here. As you can see, a lot of the extra devices have been added to what used to be a simple circuit. To make things more difficult, an optocoupler's gain varies wildly over temperature and lifetime. And since it appears in the feedback loop, this gain variation makes loop compensation a real challenge. The LT3573 presents a better way to implement a flyback inverter. The first thing you notice is that the LT3573 circuit is very simple, with no optocoupler or secondary side regulator needed. What you see here is not a simplified schematic. One convenient property of a transformer is that the primary winding voltage is always proportional to the secondary winding voltage. For a flyback, when the switch is off, the output diode connects the output voltage to the secondary winding. This means that the output voltage actually appears on the primary side of the transformer, and the voltage here is Vin plus Vout if using a 1-to-1 turns ratio transformer. This is very useful because if we subtract Vin, the output voltage information is now available on the primary side with no need for an optocoupler. This is exactly how the LT3573 regulates the output. It senses Vout back through the transformer. The bad news here is that this is not a constant voltage and is only present when the switch is off. In addition, this reflected output voltage also changes as the load current changes, which affects load regulation. Innovative internal circuitry inside the LT3573 takes care of these issues and provides excellent line and load regulation of better than plus or minus 3%. To see how this excellent regulation is achieved, let's look at some typical waveforms. Here are the current waveforms for the primary and secondary windings of the transformer. Below is the voltage waveform of the switch node. The primary winding current ramps up from the positive input voltage. The secondary winding current decreases due to the secondary winding being in the opposite direction. The switch node is close to 0 volts when the switch is on, and Vin plus Vout when the switch is off. On this waveform, there is a slope caused by the parasitic resistance in the secondary winding and the output diode. If not sensed correctly, this could cause poor load regulation. However, if you sample at the point the secondary winding current goes to 0, there is minimal error and you achieve excellent load regulation. In addition to the benefits of this unique regulation method, the LT3573 helps simplify the design of an isolated flyback inverter. Standard off-the-shelf transformers can be used, or custom transformers can be used. You choose. The output voltage is also set using 2 resistors, and compensation is now simpler. By eliminating the optocoupler, the LT3573 makes the solution smaller, more reliable, and simpler to design with. Please visit the website for the LT3573 datasheet and many more product ideas. Thank you.